Chapter 2, Lesson 5 of Advanced Algebra, we're looking at graphing absolute value functions, and in this lesson we want to look at how to graph an absolute value function by writing two linear equations. Writing two linear equations to graph these absolute value functions is really an application of the definition of absolute value, which we've used earlier this year to solve absolute value equations. And we're going to graph these equations. We're going to get two linear equations. We're going to graph those. The intersection of the lines will be the vertex. Again, that's that important point that we want. And then here's something new that we didn't talk about yet, but it's very important. If the absolute value is positive, in other words, if the original absolute value equation in the expression is positive, the v will open up. If the sign in front of the absolute value is negative, the v will open down. And that's going to be very important to know when we go to graph these, because we are going to have two lines, but we're only going to use parts of these lines in order to actually come up with the absolute value graph. So what we're going to do is we're going to take an absolute value equation like this, and we're going to solve it like we did earlier this year. So we need to isolate the absolute value, and to do that we're going to subtract 5 from both sides. And then you remember, once we have the absolute value isolated, it gives us two equations. It gives us x minus 3 is equal to y minus 5, and then x minus 3 is equal to the opposite of y minus 5. So that is something we worked with earlier this year, so we're just applying what we already know. Now before I move further, I want you to notice one thing. In front of the absolute value sign here, notice it's positive. So that's important to notice first. We should have looked at that first. The absolute value is positive, which means my equation when I get done, or my graph when I get finished, is going to open up. The v is going to open upwards. If this absolute value sign had a negative in it, the v would open down, and that's very important to know once we get to graphing these linear equations. So we have these two equations, and now we solve each one of these for y. And so I have y is equal to x plus 2, which is a linear equation, y equals mx plus b. And we have y is equal to negative x plus 8, which again is a linear equation in slope-intercept form. So we're going to use those two lines, and we're going to graph those two lines. Okay, so we have our axes here, and again we're going to label these x and y. Now I notice that this is an 8 right here, and so my graph isn't going to accommodate those 8s. So I'm going to go by 2's instead of by 1. So this is going to be 2, and then this is 4, and this is going to be 6, okay? And then the same thing here. This is going to be 2, this is going to be 4, this is going to be 6. You know, that'll help me graph these lines or fit them on my graph. All right, so I'm going to graph this equation on the left, which is x plus 2. So I have a y-intercept of 2. So I'm going to graph the y-intercept. And then I'm going to use the slope, which is 1. So I'm going to go up 1 and over 1. Now remember, these tick marks are 2. So I'm only going to go up a half, which is 1, and over a half, which is 1. So then I have my equation. Now I want to graph that, but I just want to graph that with a dotted line or a dashed line, because only part of this line is actually going to be my absolute value function. So only part of this is actually going to be my absolute value. So I want to just go ahead and do that. And again, I probably want to make that a little bit lighter, so I'm going to do a little fancy work here. I'm going to slide it down and make it just a little bit light. Okay, so that's one line. So then I want to go ahead and graph the second line. So I have a y-intercept of 8. So 2, 4, 6, 8 is my y-intercept. Now this has a slope of negative 1. So I'm going to go down 1. That's negative, and then over 1. And so I have my 2 points, and then I'm going to go ahead and graph that line. And again, I want to make it very light. Oops, it didn't go off. All right. Let me back that up. Let me do it this way. Okay, so then I have my second line. And again, this is just going to be very lightly done, because only part of this line is going to actually be my absolute value. So I have my two lines then that came from my absolute value equation. Now the intersection of these two lines is going to be the vertex of my absolute value graph. So this is going to be my vertex right here. Okay, and then I'd want to label that point, and so I could do it by doing b over 2 or b over 1, which is going to be the opposite of b over 1, which is going to be 3, 5. So this is going to be, the vertex is going to be at 3, 5. Okay, Now, because this is positive, this is going to be an absolute value graph that opens up. So I'm only going to use the vertex and the parts that open up. So now my final graph, I want to use a solid line now to actually graph these. And so this is going to be my vertex, and so I'm going to have my absolute value up this way, and I'm going to have my absolute value up this way. So this would be the absolute value graph that I use using the two linear equations. So you'll notice I don't use this bottom part because the absolute value opens up. So that would be that, and then we would put our equation on here. And so I have my absolute value equation graphed using two linear equations. So we take what we know about absolute value equations, we solve the absolute value, come up with our two equations, solve them as linear equations, and then we graph those linear equations. The intersection point is going to be our vertex, and then if the absolute value is positive, it will open up. If the absolute value is negative, it will open down.